Hi everyone. So in this video, I will be discussing regarding the principal component analysis, popularly known as PCA for short. So if there are many variables in your data, it can often be difficult to detect difference between a group or create a create a good visualization. A useful tool in this context is principal component analysis, which can reduce the high dimensional data to lower number of variables, and that can be visualized in one or two scatter plots. The idea here is to compute new variable called principal component that are linear combination of the original variable. These are constructed with the two goals in mind. The principal component should capture as much as variance in the data as possible, and each principal component should be uncorrelated to the other component. You can then plot the principal component to get a lower dimension representation of your data, which hopefully capture the most of this variation. So by design, the number of principal component compute are as many as the original number of variables, and with the first having the largest variation, the second having the second largest variation, and so on. So we hope that it will suffice to use just as a few of these to represent the most variation in the data, but it is not guaranteed. So principal component analysis is more likely to yield a useful result in the several variables are correlated. So to illustrate this principal component analysis, we'll use the data set uh, from the Cherry 10 Tenovichik, that is 2010. It's contain the measurement of wheat kernels for three variety of wheat, and it is I have already downloaded that seed data set. You can search in the Google, you will find that. So if I run this, I'm just putting that path for that particular file in the path object, and I'm reading that using the so it's a text file, so we are using read dot table function, putting this path and the column name. I'm just uh, giving those column names and putting that into the seed object. So we are interested to find out if this measurement can be used to distinguish between the varieties, and so we have loaded this, right? So if you like a if you like, and you can think of the principal component as a weighted average of variables computed for each row in your data column, or to a categorical factor which we'll see in coming videos. So let's do one thing, and I will use the factor, right, to make it categorical and put it into C variety. So if you want to know what is a factor does, the function factor is used to encode a vector as a factor. The term category and numerator type are also used for a factor. So let's load the ggplot2 and ggle library, and let me run this one. So let me zoom it. It's a very detailed and very busy chart here. The amount of information in this scatter plot is like it's overwhelming. And it would be nice to able to present the data in single scatter plot without losing too much information, and will therefore compute the principal component using the PRCOM function. And it is usually recommended that PCA is performed using standardized data, that is using data that has been scaled to have a mean 0 and standard deviation 1. And the reason for this is that if we put all the variables on the same scales, if we don't standardize our data, then variable will have the high variance, which is completely dominate the principal component. This isn't reliable as the variance is affected by the scale of the measurement, meaning that choices of the measurement scale would influence the result. So we don't have to standardize the data over ourselves. So this can be done by using the PRCOM function, and there's a argument called center. We have to just make it true to get mean 0, and scale true to make it standard deviation as 1. So let me close this, and let's run this. So center will make the mean 0, and scale will make the standard deviation as 1. So let's run, and PCA run. To see the loading of the component, that is how much each variable contribute to the component, simply type, we just type the PCA and you will get that, as you can see in the here, right? PCA1, PCA2. So the first principal component is more or less a weighted average of all the variables, but has a strong weight on the area, right? And parameter, kernel length, kernel width, and groove length. So all of which are measured of a size. We can therefore interpret it as it's as a size variable. The second component has higher loading for compactness and asymmetry, right? Asymmetry, meaning that is mainly measure those shape features. To see how much of this variance each component represent, we can use summary function, and let me run that. So the first principal component account for 71.87% of the variance, and the first three combined are account for 98.67. Right. To visualize this, we can draw a scree plot which shows the variance of each principal component. The total variance of the data is the sum of the variance of the principal component. So let me do that. So we can use this to choose how many principal component to use when visualizing or summarizing our data. In that case, we look for an elbow, like is bend, after which increase the number of component does not increase in the amount of the variance explained. So we can access the value of the principal component using PCA dollar sign and X, right? And let me load this. And yeah, sorry, this one. And like this, we can just to check the first two component are really uncorrelated or correlated, right? So in this case, most of the variance is summarized by the first two or three principal components. It appears that we have successfully reduced the seven variables to a two three variables, right? And we should make visualization much easier. So the GG45 package contains the autopilot function for PC object that create the scatter plot for our first two principal component. So if I run this one, so this is much better, right? The group are almost completely separated, right? We show that the variable can be used to discriminate between the three varieties. The first principal component account are 71.87% and the total variance in the data, and the second for 17.1%, 11%. And if you like, you can plot the other pair of principal component, then just component 1 and 2. So in this case, the component 3 may be interest in as various almost high as the of the component 2. So you can specify which component to plot with the x and y argument. So we can add that x2 or 3, right? So here the separation is nowhere near as clear as is the previous figure. So in this particular example, plotting the first two principal component is the better choice, right? So this one, this is the one which has better clarity. So we'll discuss this PCA in more detail. It's very much important topic. This is just to give you a very brief introduction in this series. Yeah. Thank you.